Welcome to this seminar. It's wonderful to have you all here. And the seminar is going to be facilitated by me. Those of you who know me might be slightly surprised that I would be facilitating this, because I'm not known to be an expert in climate change, which is about the best British understatement you'll ever hear. But I'm here because of a career experience I had about 14 years ago. Then I started working in a Washington, D.C. consulting firm, and it's the first time I'd ever worked in such a place. And the vice president of the firm came up to me one day and said, "Peter," he said, I hear you just turned down a contract with a potential client." I said, "Yeah." He said, "Well, why?" I said, "Because, as I told him, I didn't know anything about the work that they wanted me to do." He was absolutely appalled, because this had never happened before in this particular consulting firm. And he said, no, you've got it all wrong. You've got to learn quickly. Next time, you don't say, "You haven't a clue." You say, "I think I can bring a fresh perspective to that." Now you know why I'm here. So this, I'm going to bring a fresh perspective whenever I get the chance, but most of the work is going to be left to others in the room. I'd just like to say something that would put this whole thing in context for those of you who are not up on climate change. Very few of the people in this room, the Humphrey fellows, for example, are not expert in the climate change, but they're the ones who have sponsored this event. For those of you that don't know, the Humphrey Fellowship Program is a non-degree program for young and mid-career professionals, each one of whom has been identified as a leader or potential leader in their countries. And they come from developing and emerging democracy countries. And there's 11 of them right now. This program has been going at Cornell for 34 years. 18 universities around the States are involved in it. It's a magnificent fellowship program, and we have magnificent fellows right here with us, 11 of them. So they are engaged in professional development, learning how to hone their leadership and managerial skills, and it's just wonderful to have them here. They come for 1 year at a time. And this seminar and the following 4 seminars have been created by them. But to put it in the climate change context, according to a new scientific report from the World Bank, who came out last November, the world is barreling down a path to heat up by 4 degrees by the end of the century. Now, to some of you, this may not seem like much, but according to the World Bank report, this will trigger some cataclysmic events, including extreme heat waves, declining global food stocks, sea level rise affecting millions of people. And they are predicting that all regions of the world will suffer, but of course, as usual, it'll be the poor people who suffer the most. However, on the bright side, the report predicts that this rise of 4 degrees is not inevitable if people can get their act together and do something about it. They might even be able to reduce it to 2 degrees rise, which is still bad news, but better than 4. So it's in that context that we're talking here. As I say, many of us are not experts in climate change, but climate change will affect every one of us in this room and everyone in the world. So it's a very important seminar series. So I've told you everything I know about climate change, and I would now like to introduce Luceline Danzige, who is one of the Humphrey Fellows. She's from Brazil, and is involved with an NGO there, and she'll perhaps tell you a little bit more about that. But she's She's very much into social responsibility and management, and she has led the organization of this set of seminars, working very closely with Humphrey Fellows and others who she'll mention in a minute. So with that, I'll ask Liz Link to say a few words, then I'll come back and introduce our main speaker of the day.
So,
Thank
you, Peter, and good afternoon, everyone. I just would like to say some 3 points. And this is the first event of 5 of them. So we will have more 5 to discuss all the questions or the issues that we will raise today. And we Humphrey Fellows are not climate experts. We are just professionals that are concerned with climate change. And the purpose here is to open a dialogue about the climate change, the challenges that we are starting to face in our countries and in the US. Which kind of problems and solutions could we find? How some countries and regions are incorporating in development process in coping with climate change in agricultural sectors and urban areas. And which tools are available or should be available? How the society is reacting or acting? These are some of the questions that we expect to address over this seminar series. Also, it's important to say that we will have a conference about climate change adaptation and mitigation in April here in Ithaca to the community. We are collaborating with them in order to raise these questions. And finally, I would like to thank the Humphrey program and its wonderful team, Peter Gregory, Francine Jasper, Michael, and the calls team, Linda McCandless, Kelly, Christopher, and the invisible people that are supporting this event. And the speakers that kindly accept our invitation, and my colleagues, the Humphreys, that accepted the challenge to talk about something that is new for everybody. And so many, many thanks for all of you, and have a good day.
Thank you very much indeed, Listening. I would like to now introduce our main speaker of the day, Dr. David Wolfe, who is a professor of plant and soil ecology here at Cornell, and he's a leading authority on climate change and its impacts on crops, soils, and ecosystems. He serves as co-chair of Cornell's Climate Change Program and chairs the Atkinson Center's Climate Change Focus Group. He has co-authored past and current national impact assessments sponsored by the US Global Change Research Program, and was lead author of both the Ecosystems and Agriculture chapters of the 2001 Climate. This report, which focuses on vulnerabilities and adaptation strategies in New York. He currently leads a national USDA-funded project focused on new tools for farm management of carbon, nitrogen, and greenhouse gases. And this might be of interest to students and faculty and others in the room. He's teaching a new course this spring entitled Climate Change and the Future of Food. So with that, thank you from the bottom of my heart to Professor Wolfe for coming here to give you a talk, and welcome, a warm welcome to you.
Thanks.
You've got 20 minutes.
20 minutes. Okay, yeah. So I was asked to kind of do a bit of a broad overview of the climate change issue with some focus on agriculture. I know some of the subsequent sessions will focus on urban areas as well, but I'll be kind of trying to do double duty, a little bit of general introduction, And I'm going to go through some slides fairly quickly. Can people hear me okay if I'm not standing right at the mic? Because I do get tempted to go up to the screen and look at some things, point out some things. Maybe I can do some of this with the arrow, because I know we are recording this session too. One thing I wanted to mention is there's this Cornell climate change website, fairly simple to remember, climatechange.cornell.edu. It's loaded with lots of good resources. On the agriculture front, it's got fact sheets on farming success in an uncertain climate, some business about mitigation, but also things from municipalities, et cetera. And we're actually doing a major revamp of that website. So there's going to be many new things to come there. So keep an eye on that site. So I always like to begin these talks about climate change, talking to separate a little bit out and clarify a little bit the natural forcing factors versus the human impacts. And indeed, the climate has always been changing long before humans were on the planet. And this record here goes back, almost 500,000 years. And the bottom trace there, the black line, is the temperature trace, showing us dipping down into these ice ages about every 100,000 years. These, the forcing, one of the major triggers for that actually has to do with astronomy and Earth's orbit shifting slightly. Earth's axis shifting slightly over certain cycles begins to drive that. But notice then there's this correlation with temperature and these greenhouse gases. The two feed forward and feed backward on each other. So a global warming can release trapped CO2 and methane in permafrost. So as we go into one of the upswings here out of an ice age, CH4 and methane and carbon dioxide are released. As we go into a cooling cycle, there can be more carbon dioxide taken up in the oceans, et cetera. So there's a lot of correlation between the two. The other thing I wanted to mention and clarify is that look at where, if we go back, keep in mind the scale of this. So this goes back about 10,000 years here. And so modern farming, agriculture, crop domestication began as we got into one of the warmer periods in a really relatively stable period. The little ice ages in here, that was in the medieval period, 1500s, 1600s. That was a dip of about 1 degree or 2 centigrade. But you can see compared to what these bigger cycles are, fairly stable. Well, let's see. The next graph is just focusing on this CO2 trace going back to 400,000 years. Notice how it goes up and down between 200 and 280 going back 400,000 years. So here's that on a different scale now, that CO2 trace going up and down between 200 and 280. There's crop domestication. And I just want to show where what's happened in just, many of our lifetimes, really. We've seen a lot of this warming happening, getting close to 1 degree C warming. When I was in grad school, CO2 levels were about 330 parts per million, to age myself, now close to 390, over 390 parts per million. And I'm going to be talking about the impacts we've seen across the globe just with this level of warming. You can see we're clear off the track in terms of historical CO2 levels, and corresponding with that, of course, because the two are linked so closely, CO2 being a greenhouse gas, we've seen that warming. The scary part is this. The so-called business as usual scenario of the Intergovernmental Panel on Climate Change indicates that at the latitudes where we are here today, we could have as much as a 4 to 7 degrees C temperature rise in the next 100 years. If you think back to those ice cycles, ice age cycles I just showed you, that's the kind of change in temperature we typically see over 20, 30,000 year cycles happening in 100 years. So to put that in perspective a little bit, it's not so much that we can't handle a little bit of warming, but this is about 100 times faster than the last ice age transition. So hopefully, of course, we hope we end up somewhere like this if we as a society choose a more clean energy approach. But what I want to point out with this graphic also is that even under sort of, I would say, the best case scenario in terms of what humans might do in terms of trying to control this thing, we're going to have some continued warming and some adaptation as well as mitigation we have to do. This is to put this put some of this climate data in a way that's a little more familiar to some people. This is the so-called plant hardiness zone map. This is a color-coded map that's been created by the U.S. Department of Agriculture periodically, always based on the last 15 years of weather records, color-coded based on how cold it gets in the winter. So this is based on winter lows. And you can see no matter where you live in the U.S., the hardiness zones are shifting. There's a climate zone creep northward. And right along with this, we're seeing shifts in, for example, minimum winter temperatures dictate not only what crops you might grow in your garden or farm, but also what insects survive the winter. And we're seeing lots of biological responses to that. So as this next graphic says, it's not just the thermometers telling us that we already are in the middle of some climate change, but the living world's responding. So this is some of my own research where we dug up historical records of the first bloom date of lilacs, apples, and grapes in the Northeast, and indeed documented that since the 1960s, 70s, these have been blooming 4 to 9 days earlier. And this is just the tip of the iceberg in terms of what's out there in the scientific literature of showing these kind of biological responses. And for places in higher latitudes, like where we are here, warmer winters really mean more pest pressure. We currently, historically, have been somewhat fortunate in this part of the world in terms of a lot of potential crop insect pests get killed off in the winter and then aren't there to pressure the farmers in the summer. But both insects and also weeds, kudzu, very notorious, invasive, kudzu, very notorious invasive weed. South of here is moving northward. In fact, some of our own modeling studies predicted this some time ago. The top graphic here is just showing as we move through the century. The dark orange area shows the area of the Northeast where the climate will be habitable for this aggressive invasive weed plant. And you can see it's kind of kudzu coming to get us across the Northeast. But this is the kind of thing that farmers will be facing and having to deal with. And a natural farmer adaptation to this will be what? More weeds, more insect pests, more insecticides, more herbicides. So we have this challenge of how do we allow certain sectors of our society adapt to climate change, and yet we also want to protect our environment at the same time. And it's just, I don't have the solution there. I just bring this up as a thing we have to think about. Trying to get through a lot of slides, I'm not going to spend much time on this, but one thing that's been sort of unexpected is we've actually been seeing more frost and freeze damage, even though our winters are getting warmer in this part of the world. And this can happen because our winters are becoming more variable. Last year was a pretty amazing example. Apples in this area bloomed about 4 weeks earlier than normal, leaving them vulnerable to a long window of time when they were subject to frost damage. And in fact, we lost 30 to 50% of our apple crop in New York State due to that, despite the fact that the average winter temperature was warmer than normal. For this part of the world, showing just some New York data, each one of these bars goes back to some long records, back to the 1870s to the most recent decade. Each one of these bars represents a 10-year average period. And you can see quite clearly that the last decade has been quite remarkable in terms of number of heat stress days and the frequency of heavy rainfall events. So in this part of the world, we aren't necessarily getting more rain, but more of the rain that we do get is coming down in heavy downpours, which of course leads to flooding in an agriculture setting, can cause crop damage, but also, in fact, more importantly often, delay farmers from getting into the fields. And in fact, the Northeast, just on that increased frequency of high rainfall, we are the worst spot in the country in terms of that trend. So it's a trend that we see across the Northern Hemisphere, actually. The reason is that with a warmer world, there's more water vapor in the atmosphere because there's more evaporation and transpiration going on. So when there is a cooling upper atmosphere event to cause rain, there's more up there to come down. But here in the Northeast, we've seen a 74% increase in the frequency of those high rainfall events. So a very serious issue in this part of the world. So all of these things are, of course, issues for farmers: heat stress, drought stress, heavy rains. The dairy industry, turns out, dairy cows, a lot of animals, but particularly dairy, they like it cool. Milk production is at a peak at fairly cool temperatures, and this is another modeling study we did down here just showing declines in milk production in the northeastern U.S. due to heat stress of dairy cows, unless farmers adapt to this by, for example, improving the cooling capacity of their dairy barns. Sea level rise, this is the historical record, again, not talking about projections for the future yet, just what we've encountered with that relatively small increase in temperature we've seen so far responding to the rise in greenhouse gases. We've seen about a 15-inch rise in sea levels in Boston and New York. That explains part of what happened recently with Hurricane Sandy. While we can't take a single hurricane event like that, and there's a lot of things that are, play a role in what causes hurricanes, and there's a lot of controversy among the climate scientists about whether hurricanes are increasing in frequency or not. But one thing we know for certain is the fact that we've had a higher sea level caused greater damage from that event than there would have been otherwise without climate change. This is just another thing on the hurricane thing. This is the long-term hurricane number data going back to the 1850s. You might argue a slight increase in recent hurricanes, but there's also the argument can be made we can detect hurricanes better. So this is a little controversial, more hurricanes, the same. It's still being debated among the climate science community. But what I have done in the lower part of this graphic is what we do know. Global warming causes warmer sea temperatures. That causes higher sea levels due to thermal expansion. Separate from the glaciers melting, most of the sea level rise we've seen so far is just due to thermal expansion. And of course that then means more coastal intrusion of floodwaters. And in addition, the warmer sea temperatures can intensify storms. So thinking of those kind of extreme events like hurricanes, I really argue that sustainable development and climate change are very intricately linked. If we don't do something to slow this down, we're going to end up spending our tax dollars on things like infrastructure repair, humanitarian assistance, community relocations, dealing with conflicts, as opposed to investing that money in sustainable projects. A little bit about farmer attitudes about climate change. The whole climate change thing, as we all know, is highly politicized. But there's some things we can say about the farmer group, and really some things we can say about the general citizenry. But certainly all farmers who really have to work with the environment are concerned about extreme weather events and uncertainty about the weather. And recent polls indicate that the majority of farmers are convinced that something's happening with their climate. Not all of those are convinced it's human-caused or mostly human-caused, but they are recognized as climate change. And also, farmers are very concerned about energy costs and energy policies and climate change policies. So in terms of talking to that audience, we also have to take that into account. And farmers are concerned often about the climate change policy reaction as much as they are climate change per se. There's a lot of things farmers can do to build resilience, and there's plenty of literature, and I've written about it, many others have written about it, and there's things that farmers are doing right now. Certainly there's some simple, relatively low-cost, low-risk things that fall into this category of diversifying the operation, and that's sort of a generalizable approach to adaptation. If one part of your farm gets hard hit, but because you have a diversified farm, another part of your farm might do better under a particular type of weather year. So this thing of adjusting planting dates, having more staggered planting dates, is one of the approaches. And then, of course, with this issue in our part of the world here of new, more pests, diseases, and weeds, really need new strategies and stay ahead of all that, monitoring those movements. And with problems of both too much and too little water, irrigation and drainage, I mentioned the cooling capacity of livestock facilities. So many of these are very straightforward. It's not rocket science, but there's a lot of constraints to why farmers might not be able to make these adaptations. One is a problem that even the climate scientists have, and that is detecting the climate change signal against the noise of normal weather variability. So it's hard to know. I've got hit by a drought a couple years in a row. Is that part of climate change or not? And that's something I think where universities and others can help farmers separate those things out. There's also issues, and this gets into the developing versus the developed world, of course, of equity issues and capital to make those kinds of adjustments. So if it may only take a little bit of money to putting in an irrigation system or a better drainage system may really save a farm operation, but if that capital doesn't exist, there won't be the ability to do that. And in addition, climate change is going to hit different parts of the world differentially. And of course, many of the developing areas don't have the extension systems, et cetera, to support farmers through those things. Another challenge, another reason why people become paralyzed and can't really adapt, even though you might say, well, we know what you should be doing. Why aren't you doing this? It's just too much information out there, a lot of information. Anybody who has tried Googling climate change, you're going to get swamped, and it's going to be pretty difficult separating out who's giving me some straight information, who's got a bias, et cetera. So it's another place where I like to think that universities can play a role. And one thing we're doing at Cornell is really working on developing new decision tools to help farmers determine when is it strategically optimum for me to make some adaptation investment. So is it time now? I've been hit enough years, and the climate scientists are telling me heavy rains are here to stay. Should I invest in a drainage system? How much should I invest, et cetera? So this is just a list of the many things that can go beyond the farm in terms of adaptation. Everything from these new decision tools, like I just mentioned, we're working on at Cornell. Of course, breeding, many things we can do in terms of breeding crops for addressing these stress problems, better pest monitoring, crop insurance programs, financial assistance, et cetera. Finally, I've got a few slides I just want to talk about the other end of the coin. So as I alluded to at the beginning, I think we really have to be working on parallel tracks at this time. And I think what most farmers, if you talk to them, with their immediate concern is coping with the inevitable, right? So adapting to climate change. And I think that's where we begin the conversation with them. But there's a lot of their own self-interest, really, in terms of trying to slow it down so it's something they can cope with. And also it makes sense in terms of profits at the farm level. So a lot of farmers, not due to necessarily becoming, trying to solve the climate change problem, but to save on their own energy bills, are looking at renewable energy on the farm. And so I think policies that support that are very important. I've taught a course called Cropping Systems Ecology, and in that I often talk to the students about how in the past century we really decoupled our animal and crop production systems. And one of the challenges for this century and the next coming decades of agricultural scientists is how do we recouple those in ways that are still economically profitable for farmers? Because I don't know what you see when you look at that picture, but I see lots of energy, carbon, and nitrogen that we can reuse. So things like anaerobic digesters, et cetera, are definitely part of the solution. Farmers are really all over this. I mean, they are interested in this. Right now, these are expensive, and there's challenges to making this something that really takes off. But I think it's, we talked about tipping points with climate change, but tipping points with mitigation and improving greenhouse gas management on farms. We get a better way to get these anaerobic digesters in more farmers' hands. Could be a great solution because it handles waste and gives farmers free energy, you might say, on their farm. Some of you may know that I also I'm co-chair of Cornell's Soil Health Program work team, and a lot of things we talk to farmers about building healthy soils is really about building organic matter in soils, which is really, of course, building carbon in soils, which is carbon that otherwise wouldn't be in the atmosphere as carbon dioxide or greenhouse gas. So it's one of these win-win strategies. Farmers should be doing this anyway because it's good for crop production, but it will help in the mitigation of greenhouse gases. This is peculiar to the US and developed world, but when you look at the US agriculture sector and what is the biggest factor in greenhouse gas management, it's not carbon dioxide and the tractor driving fossil fuel emissions, it's nitrous oxide emissions. About 1% of the nitrogen fertilizer that's put on soils across the globe can be emitted as nitrous oxide, which is a very potent greenhouse gas, over 300 times more potent than CO2, and its warming potential. So is the big issue, actually, the low-hanging fruit in terms of the US mitigation. So things like using legumes in rotation, which can provide nitrogen instead of synthetic fertilizers as part of the solution, and developing new tools for nitrogen management. And this is a new project that was, I think, mentioned in my introduction project involving people at Cornell, Harold Van Ness, for example, who's got this Adapt-In program, that's a nitrogen management program, but many others, developing new tools for essentially developing sophisticated carbon calculators for farms, and also developing tools for policymakers to look at policies to incentivize greenhouse gas mitigation. Now, in developing countries, it's not nitrogen usually. It's much more about CO2 and deforestation as sort of the big issue in terms of the agricultural contribution to greenhouse gas emissions. So what can we do here? And some people in this room who are from these places may know, have many good ideas that we need to listen to. I've had a project in Zambia. We had a paper in the Proceedings of the National Academy of Sciences that summarizes this, kind of an exciting project. It's a co-op of about 20,000 of the poorest of the poor farmers who, nothing to do with climate change, but they were adopting more soil conservation practices, mostly just to improve their food security. And also developing a major agroforestry project where they're doing a major planting, over 1 million Faidherbia albida trees, which are nitrogen-fixing trees, intercropped, which can provide nitrogen to their farms. But those trees also sequester carbon. So we were working with them on also getting credit for the carbon they're sequestering at the same time that they're using these for their productivity. So I really like this kind of project as sort of another one of these win-win things where adaptation and mitigation sort of work together. And this is my last slide, just coming back to this linkage between climate change to sustainable development. This is kind of the other side of the coin. The part of this is sort of a mutual solution to these things. Sustainable practices like conservation agriculture, those can help reduce greenhouse gas emissions, sequester carbon, but also, for example, make soils have better drainage capacity, better water holding capacity to buffer farmers from drought and flooding, et cetera. So another kind of win-win angle to the whole thing. So I hope I kept closely to my time somewhat. I don't know where I went, but I'll stop there. Thanks.
Well, thank you very, very much, Professor Wolf, for a clear, concise, and very thought-provoking presentation. We very much appreciate it. If it's okay with you and all of you, I'd like to go into a discussion after we've had the next two speakers speak, if that's okay. And the next speaker is Nadica Jovanovska from Macedonia. She's one of our Humphrey Fellows. She's a project manager on a World Bank finance project in Macedonia and a part-time lecturer at the Southeastern European University there. She's pointed out this is the only multi-ethnic university in Macedonia. So she knows that has incredible challenges in teaching and all the rest of it across ethnicities. So she's covering the agriculture sector in this World Bank work and the European Union approximation work, trying to make sure that the Ministry of Agriculture develops the required systems for this Common Agriculture Policy, or CAP. So it's an extremely important world that she's working in to try to get Macedonia more closely to the European Union. She's an economist and is currently finishing her PhD in Macedonia in territorial marketing as a strategic element for development of the regions in Macedonia. So she pointed out to me that, which I knew already, that she's not an expert in climate change, but this work that I just described is so tied up with climate change. The climate change is of intense interest to her, and she's one of the many people who are delighted that this seminar series has been put on. So with that, Nadica, you have 15 minutes or less, as we started a bit late. Nadica, by the way, if she suddenly stops in the middle of her talk and goes to sleep, the reason is because she arrived at 5 o'clock this morning from Macedonia, and I want you to excuse her if she misbehaves.
Thank you very much, Peter, for this nice introduction. Thank you very much to all. My name is Nadica Jovanovskaya, and I'm already introduced. I will talk more about the climate change and agriculture in my country specifically. I'll give you an overview about the agriculture sector in my country and findings, actually, what's happening now in regards to the climate change and what are the next steps, what the government and the farmers in the same time together. I'm mentioning this because it's very important we get huge support from the World Bank and other donor agencies. So together with them, we are trying to implement adaptation options, adaptation measures in order to react on these climate changes that are affecting our agriculture sector. These are some pictures that if we say that, that they're in Africa or in the US in some places, I'm not sure, or in Europe, you can find similarities. Why? Because we are all facing with the climate change and a lot of floods, a lot of heat waves and less decrease of the water in some lakes and increase in US and the hurricane. So I put these pictures because I wanted to emphasize a sentence that the World Bank is always repeating to us, that the climate change will increase risk and volatility in agriculture. We need to be aware, we need to react as much as possible. These are some photos from Albania, which is our neighboring country, where in 2007-2008 they faced with a huge floods. I don't know if you pronounce it well. And in the same time, this is a picture from Macedonia, from Doiran Lake. It's called Doiran Lake, where every year we are facing with a huge problem of decreasing the level of the lake. That's why the government of my country and the Ministry of Agriculture, who is responsible for the climate change and agriculture sector in general, is trying to do something to adapt to the climate change. I'll go through, first I will speak about the agriculture sector in Macedonia, then I will say why I'm actually speaking about agriculture sector and how influences this sector to the economy of my country. Then the agriculture and the influence of agriculture to the environment in my country, and the impact of climate change to the agriculture and the next steps or the adaptation measures. This is Republic of Macedonia, and Macedonia is in the southeastern part of Europe, actually the western part of the Balkan Peninsula, bordering Greece in the south. In the north it's Serbia and Kosovo. To the west is Albania, and east part it's Bulgaria. The territory, it's pretty small, 25,713 square kilometers, and we are 2 million people, inhabitants in this country, trying to fight with the climate change. And around 20% of the country is agricultural land, 19% are pastures, and 37% are covered with forests. I think on this graph it's more clearly presented. 25% it's cropland, and from this 25%, if we take it as 100%, only 10% are really irrigated, and everything else it's actually needs of this cropland rain-fed. And I'm mentioning this because later, when I will show the climate change, the results and predictions, we'll see that opposite to this New York area, we are facing with really a higher temperature, lower rain, and it's making a huge problem to the agriculture sector. Lakes are just 2%, and water is something that we really needed. Why we need this adaptation? Because agriculture in Macedonia, it's a very significant sector in terms of employment, rural livelihoods, food security and export. 19% of the population are employed in the agriculture sector. And 12% of the GDP is derived from the agriculture. There is something that it's a 12% of the GDP, but again, if we talk with the farmers and there was analysis, we came to the point that more than 36% of the Macedonian rural population earns less than $5 per day, and is highly vulnerable to any change in the agriculture income. Agriculture is highly climate sensitive in our country, and those that can feel that are the rural population. If we don't adapt and if we don't take any steps in regards to the climate change, then the inequalities between the rural population and the rich will be higher, and the vulnerability will be higher. This is graph. I'm not sure if the English translation is like a spider graph. I don't know how you're saying it. That's the Macedonian name. That I took it from concept note that is prepared together between the World Bank and the Ministry of Agriculture. And I put it here because I wanted to compare the Macedonia and the other transitional economies in the ECA region, which is the Europe and Central Asia region. There are 9 vulnerability indicators, and if we see on this graph, we are not more or less vulnerable. We are somewhere in between compared to the other transitional and post-transitional economies of the Eastern Europe. But there are 3 indicators that we should take into consideration and we are facing with and are very, very influential to the agriculture and future development of the agriculture. This is the soil degradation, then the percentage of share of the food in the total household expenditure, and GDP that derives from the agriculture. Why they're very important? Because if we compare it with the Western high-income European countries, where we are aspiring to enter the European Union, so we want to be comparable with them, even if we cannot now. The population that is employed in the agricultural sector is 4.5%, and in our case it's 19%. So we really need to adapt the climate change. Then the GDP from agriculture in Western European countries is only 2%, and in our case it's 12%. So it's really important, and we need to work on that. And based on what I said in regards to the economy and regards to why we need to compare with the Western countries and why we need to work on these adaptation measures, is that we are now a middle-income country. That's how we are analyzed by the World Bank and other institutions. But after the independence, which was in 1991, we are a pretty new country. Agriculture is a very stable contributor to the Macedonian economy, and the average annual rate is increasing. In the period from 1990s until 2000, it increased 0.2%. The main commodities that have a significant contribution are to the average level of agriculture production are grapes, cow milk, tobacco, chilies and peppers, wheat, apples, and tomatoes. And regarding to grapes, I would like to mention that actually the most vulnerable areas, we'll see when I'll show you the slide about the adaptation option, is the central region of my country, where the farmers grow grapes. So we need to react here, and also we have a lower rainfalls in that area. So I mean, a huge percentage of the export is from the wineries and wine companies who are buying the grapes from the farmers. So it's influencing the economy. If we say that it's a very important sector to the agriculture, and plus if we add the agro-processing sector, then 16% of the GDP it's coming from this agriculture sector and agro-processing. In regards to the economy, we mentioned that it's important. In regards to how it influences the environment, and also what I mentioned to the vulnerable indicators, we have a problem with the soil degradation and water lodging. The result is the unsustainable agriculture practices. The farmers are not aware and about these climate changes. The farmers are a lot of times we are facing with poor agricultural practices at the farm level, improper crop rotations, burning of crop residues, poor water management, and all that. It's increasing the soil erosion. So we just not have the climate change as a problem, but also the human factor that should be trained how to take care of our agriculture sector. The historical data are showing that actually we started to have that Macedonia is affected by the climate change. We have highly variable climate, increased in mean temperature, moisture deficit, increase in severity of extreme events. This is better explained through the concept note that I mentioned, and this is taken from the World Bank concept note, where they say that 1.9 degrees Celsius will be increase in mean annual temperature will be done by 2050, and in summer 2.5. It's a lot. I mean, I just came from Macedonia where it's 50 degrees Fahrenheit, and we are in the same continental climate with Ithaca. So then a decline in mean annual precipitation by 5% by 2050, and in summer 70%. There will be increase in exposure to new pests and diseases for agriculture, crops, forests, and livestock. This will, how will affect the agriculture? Will water deficit to crop production, errant and risky production environment, longer dry periods, and potential for drought. Then it will be an ineffective soil drainage, damage to soil structure, reducing land productivity, and exposure to new pests and diseases. That's very important. That will challenge existing plants and animal genetics and management. I will not go through this whole adaptation option. I mean, if someone wants to read it additionally, you're welcome. I will just mention that these are the steps that we are undertaking, that the ministry is undertaking in order to adapt to the climate change. For example, invest in research and extension services to enhance the capacity and deliver information to the agriculture sector. When we talk about the rain-fit crops, development of new genetic varieties of crops with higher resilience to increased temperature and lower precipitation and droughts. Irrigation, as I mentioned, implementation of a Vardar River watershed management. This is the central area of my country where we have grapes and we need the water. And at the end, I would like to, because we are running out of time, I'm a bit fast, but at the end, I would like to say that it's an incredibly significant sector. It's a sector that needs adaptation options. Also, it's not that the only thing that Macedonia needs this in order to still develop the agriculture sector, but we have a requirement by the European Union, and we also have to provide these agri-environmental measures, take care of the climate change in order to be part of this European family. So shortly, I tried to explain what's going on in my country, and if you have any questions or you're interested more, we can talk later. Thank you.
Thank you very much, Melissa. If you have any questions for her, I would ask that you bring them up later after our next speaker. That was very, very fascinating, and I really appreciate your presentation, Nadica. I know it's always frustrating to have to stop in a certain period of time, had the embarrassment with the Humphrey Fellows of trying to coach them and how to give talks and so on. Most of them give better talks than I do anyway, but trying to coach them, keeping to time. And I gave the seminar and then went over time, so they haven't got a very good leader in me. But our next speaker is Maina Dital from from Nepal. She's a senior journalist there. She works for a newspaper called Kantipur, which is the country's leading newspaper. Her articles are on news in agriculture, food security, climate change, economic development and gender issues. And they're not only published in Kantipur but also in the Kathmandu Post. She has over 10 years of experience at this, so she's come to us as a very seasoned journalist, and already people around Cornell are using some of her skills and experience to contribute to various projects here. So with that, I will ask you, Maina, to present your talk in 14 and a half minutes. And thank you. And then we'll hopefully have time for discussion. Thank you very much.
Thank you, Dr. Gregory. It's really wonderful opportunity to make this presentation about climate change, its impact, adaptation, mitigation in the context of Nepali agriculture sector. I would like to start my presentation with this outline. Because we don't have much time, so I will skip some slides maybe. This is general introduction of Nepal. Nepal is a small country which lies between two giants, India and China. Population, it has around 27 million population and 147,000 square kilometer area. So topography-wise, Nepal is divided into three main regions: mountain, hill, and Tarai. The top one is mountain, then hill, and then Tarai. So hill shares largest portion, 42%, but in terms of agriculture production, Tarai contributes largest portion. And out of total lands, 3.9 million hectare is cultivated, and Nepal agriculture sector shares 1/3 portion in national GDP. It's around 33%, and around 75% of population is actively engaged in agriculture sector. So agriculture is the main source of national economy. If we talk general feature of agriculture sector of Nepal, it's mainly weather-based farming. Though Nepal has huge potentiality in water resource, but we could not have exploited huge amount of water in terms of irrigation. So only 22% of the land is irrigated in Nepal. So we have to rely on the monsoon and then other weather-based farming. So crop-wise, we have mainly two types of crops: cereal crops, maize, rice, wheat, and barley. And so on, and then cash crop, tea, coffee, sugarcane, cotton. These are the main cash crops. While talking about climate change, I would like to talk a little bit rising temperature, how Nepal has been affected with this rising temperature. Nepal's shares in climate change is quite negligible. It's 0.025% compared to even India and China. I think India, it has 5.75 something, and China 23.33%. But still, it's highly vulnerable to climate change impact. There was a record from 1975 to 2006. The temperature was increased 1.8 degrees centigrade, and annual increasing rate is 0.06 temperature degrees Celsius, and it is projected that it will further increase, and by 2030 it will be around 1.2 degrees Celsius. And this picture It's called Imja Glacier. How there is difference in terms of effect of global warming in Imja Glacier Lake. This lake lies nearby the Mount Everest, the tallest mountain in the world, in northeast side, I think. And in the top picture, a deep layer of ice was covered the Imja Glacier in 1950s, but after 2 decades, that Imja Glacier was converted into the lake, Imja Lake. So you can see water here. And this picture, you cannot see the water here. And this picture was taken in 2007, and it found that 42 meters depth. So we can see the difference, how our Himalayas are affected by the global warming. So I presented that Himalayan because our source of water comes from Himalaya, and agriculture has direct impact from that. So what kind of impact are we facing in agriculture sector? Nepal agriculture sector, as I said, that it's highly dependent in rain-fed agriculture. And like many other countries, we are also facing the problem of drought, floods, landslides, hailstone, cold wave, heats, etc. And we can see this picture, how Nepali people have difficult lifestyle when it comes floods, landslides. And this picture, last year there was a landslides. It happened during summer season because of avalanche. And I would like to present a case study of 2005-06. In eastern Tarai, eastern part of Nepal, there was a rain deficit due to early monsoon. Because of that, nearly 10% of cultivated land was left uncultivated. But at the same time, there was heavy rain in western Tarai, and it reduced production by 30%. And at that year, overall production was reduced by 12.5%. And here is another case study of Mustang District. It's a Himalayan district. It is also highly affected by the impact of climate change. And in 2012, farmers faced a lot of problems because of climate change impact, and it damaged crops because of untimely and unpredictable precipitation. And there are media reports that there are cases of early flowering, like Professor Wolf mentioned early flowering in apple, but it has some positive impact too. Basically, this district is very cold temperature, so normally they cannot grow vegetables like other areas. But because of this climate change, now they have started to grow new vegetables such as cauliflower, tomato, cucumber, so it has positive impact too. So it's called now, those districts have turned into greener than the few decades ago. Climate change has direct impact on our food security, because Nepal is one of the highly food insecure country. In 2012, it was in 60th position in Global Hunger Index, which has increased than 2011. And it is WFP claims that in Nepal, around 37 million rural people are still food insecure, though it's quite debatable. And still, there are 43 districts are facing food deficit, so those district needs food support from international community and government. And food security is important because Nepali average household income, 78% of household incomes are spent on food, to buy food, so it's directly connected to their day-to-day life. And this chart is about import and then food production, cereal food production. Between 2007 to 2011, the average production was 8,334,000 metric ton, which increased in 2011 too, but in 2012 because of monsoon, they did not get enough rain that year, so total production was decreased by 7%. And when our production decreases, then we have to rely on the imports. So they are projecting that in 2012-13 we need to import 387,000 metric tons cereal products. Climate change has also impact on livelihood because of changing weather condition. Farmers have started to reduce their livestock numbers because there is no grassland available compared to couples of years before or 1 decade before. Also, some farmers, they have changed their occupation. Let's say from agriculture to hotel management, hotel business, or many Nepali from rural parts, they have migrated to urban areas and then also foreign lands for the foreign employment. So nowadays, remittance has become second largest contributor in our economy. So what is our government doing in terms of mitigation and adaptation? Government of Nepal has been trying to cope up with those impacts of climate change. So it has already signed in some international instrument like UN Conference on Environment and Development and Kyoto Protocol. So after signing in Kyoto Protocol, it has established development mechanism. Under that, different projects are running to deal with carbon trade. I'll talk a little bit about it later. And there are some other national instruments too. This picture, maybe some of you are familiar with this. In 2009, Nepal's government organized a cabinet meeting on the base camp of Mount Everest called Kala Pathar. The main objective of that meeting was to give message to the international community that Nepal's Himalayas are in a big threat and Nepal is going to face severe threats of climate change. So it was trying to draw attention of international community. In terms of mitigation, there are some programs are running in government level, national level, and local levels. There are some agroforestry programs, community forestry management. It's quite successful model in Nepal. Recently, some community users groups have also awarded under carbon trade deal, and this news was about that. And also there are some alternative and renewable energy like hydropower, small and big scale, biomass, biogas programs. As of 2009, it is said that 2.1 million Nepal earned 2.1 million by running clean energy projects, and around 40,000 biogas plants are registered for the carbon trading. So it's quite encouraging. And Nepal government claims that around 56,000 tons CO2 was reduced yearly since 2006. In terms of adaptation, people are shifting to off-farm employment, as I mentioned earlier, and migration. And some farmers, they have shifted their crop pattern from from cereal to vegetable farming. Also, like they are doing diversified in livestock rearing also. And some farmers have also trying to adapt like a different kind of technique in cropping, like water efficient cropping, like a system of rice intensification and agriculture biodiversity. These are some efforts in adaptation. And also there are some programs related to integrated soil and water management practices, crop varieties, farming practice, harvesting, and rainwater usage. And this picture is, I think it's a rainwater usage, a plastic pond. Though government and non-government organizations have been trying to cope up with the challenges of climate change, but still there are numbers of challenges. Our main challenge is big gap between policy and the implementation. Government is always willing to adopt new policy to sign international instrument. Also, it formulates different kind of policy in national level, but they rarely implement in a field level. That's the main challenge. And there are resource crunch, low investment in agriculture, and political instability is another challenge. Since 2006, we are moving through a long transitional period. And also, there are challenges of awareness and capacity to adapt CCC, research and extension issues is there. And finally, there are some issues. We need to pay attention for the location-specific adaptation strategies, and we need to encourage sustainable farm management. Since we are running out of time, so I'll not go through all of this. And last, I think we need to give some incentive to farmers, because Nepali farmers cannot compete with all those challenges, faced with all those challenges. And so they need to get some incentive in terms of fertilizer, agriculture instruments, and other things. And there is need to develop heat drought resistant varieties, and these are some issues that we need to focus on in coming days. And also, like, Nepal government can initiate to work jointly with other neighboring countries in terms of cooperation and coordination. These are some issues. Thank you very much for your kind attention.
Thank you very much indeed, Mina. Very educational. It's incredible to see how climate change, when it gets down to a particular country's situation, has such a massive effect in so many ways. And so we've just had two examples of that. Well, I hope all of you can stay for some discussion now. The situation is that Chris tells me, who is, by the way, kindly doing the videography for this, he tells me that the room is well covered in terms of audio. We don't actually have handheld microphones, but he says we don't need them. And I would say particularly if we speak up when we ask our questions and when the replies are made. So I'll ask the speakers to stay where they are, but to speak up when they're asked questions, and for the questioners to speak up too. So let's open the discussion. Does anyone have any questions or comments they'd like to raise? Yes, please.
I'm interested in how climate change affects women's workloads in Nepal particularly, but also in Macedonia, if you've noticed effects from that.
So how climate change affects women's workload? Who would like to answer that? Okay, Nadisa.
Regarding Macedonia, the government is the one who is supporting the women farmers, and there are subsidies where they are actually just for women farmers and for women that are starting a business in regards to agriculture. And in that subsidy, there is a measure, agri-environmental measure, which is not something new invented by our government, but it's a requirement by the European Union. So we are just adopting that, and they should submit some requirement by the government and then receive money. If especially they're producing organic farming, if they are taking care of the environment, So they get more money from the government in regards to subsidies. And there are another EU funds that are also given by the European Union, like pre-accession funds, and the women farmers have are really supported. So we are supporting them.
I would like to add some points in context of Nepal. In Nepal's agriculture, women are the main workforce, labor force in agriculture. So now, in recent years, since men are going outside for the employment, so women are the only labor that engage in agriculture sector. So impact of climate change on women is highly, it has direct impact because they are engaged like different kind of activities in not only in household but also in field level. So they are directly responsible to carry out those activities too. So we have to pay attention on from their perspective too. So nowadays government is also trying to target them, like they are conducting some training programs, capacity buildings, and some kind of incentives focusing on women.
Thank you. Are there any other questions or comments? Professor Barker.
I'd like to know your prognosis for Roosevelt Island.
Yeah, this is where we have the tech campus. A couple of us did email a few higher ups at Cornell and indicate that that's not, it's a kind of a risky area. At some point, it depends on how the projections of sea level rise play out. If we're on the very low end, I suppose there's some simple things that can be done to protect it. If we're on the high end, which goes up to 4 feet of sea level rise, by the end of this century, there's going to be some real challenges unless whoever the powers are at that time decide to build a seawall around it. So maybe that'll be our next campaign, next Cornell campaign. I want to make a comment about, one thing that struck me is the data for Nepal about the household, 78% of the household income being associated with buying food for the family. And I think that's a big distinction between a place like the U.S., where it's a tiny fraction. And so it makes the impacts on agriculture very different here compared to Nepal. I think in both places the farmers feel it directly. But the difference is the impacts on agriculture here, by far the majority of the citizenry, 98%, hardly feel it because food is a small part of the budget. And even with like this major drought we just had here in this country, the projections are it won't affect food prices that dramatically here. So I think compared to some other issues you cover in this series, like in urban areas, I think maybe there's less separation that way. But in terms of impacts on agriculture, I think in developing countries, much more of the population feel it.
I think you also need to think about the Himalayas in general. There are 8 major rivers in the Himalayas. That going from the Yellow all the way over to the Indus. 40% of the world's population depends upon its food supply, food security from those 8 rivers, and more than 40% of the poor. And so even without global climate change, we have a serious problem with those rivers because the demand for water, not for agriculture, which takes 80%, but the demand for water now, for hydropower and so forth, 7 of those 8 rivers have their headquarters in Tibet. And the Chinese are building dams, and the Chinese are interested in hydropower, not in agriculture. How does that affect the deltas and so forth? So what I guess I'm saying is without global climate change, the Himalayan area is extraordinarily important.
Yeah, that's a fascinating point, Professor Barker. Thank you for bringing that up. Any other comments or suggestions?
So I just realized that how the different is the impact between developing and developed countries. You are worried about the policies, But we are worried, and I can say about the Brazil, it's the same case. We are worried about the implementation of the policies that we already have. So in the future, we have new policies, but the policies are not implemented. We have a lot of causes, but I think the level of the education is very important, because people they even know which policies that we have available. So I think we need to invest more when we are trying to develop some tools for the farmers around the world.
I think there's all kinds of, it's fascinating to look at some of the literature on why even people who are aware of climate change, are convinced that climate change is really happening, become paralyzed for various reasons in terms of doing anything about it, changing behavior. And I think each country's kind of got its own issues there, why things don't actually happen. Even often in people's own best interest, they don't move forward on things, and it's sometimes maybe being overly optimistic that somehow it won't affect you personally, or various things like that. But that whole thing of how human perceptions affect behavior modification in terms of responding to climate change is a really important area, I think, of research these days in terms of how we can communicate with people to get people to act, not just talk kind of.
Very well then. I think with that we had better wrap up now. And thank you all for being here. Let's have another round of applause for our speakers.